I guess we can begin now. Good morning, everyone. I'm Dr. Chow, professor of English from Valley City State University. I'm going to chair this session, which is on the role of semantics and pragmatics. As you just saw from the slides, each presenter will have 20 minutes to present the paper, and then we'll have 10 minutes for questions and answers. So if you have questions, you can put it in the Q&A section or in the chat room, or you can also raise your hand so that you can speak out your question. So the first speaker, we have Vervi Veman from University of Tartus. Her topic is the role of semantics in the acquisition of noun class morphology. So here we have Vervi. Thank you. You can begin now, Vervi.
Yeah, hi. Just sharing my slides. Can you hear me?
Yeah.
Okay. Good morning. Thank you for being here. And it's evening for me, so it's a little disorienting. But I'm glad to be speaking in this session. Unfortunately, I'm the only one of 4 co-authors who have participated in this research. So I'm speaking on behalf of my colleagues, Serge Sanya, Dunstan Brown, and Marilyn Veman, who are all at the University of York in England. I'm speaking from Estonia, and we're going to be talking about the acquisition of noun class morphology in a language called Egima, which is spoken in southern Senegal. There, so you can see on this map, Senegal is on the western edge of Africa, and the red arrow shows where Egima is spoken in the very southern area of the Casamance in southern Senegal. It's called Gujula Egima. It actually is known by various names, Banjal as well, and it's a Niger-Congo language in the Atlantic family, a Jola language. And Egima itself is spoken by about 13,000 speakers, estimated, across about 10 villages in the Casamance outside of Ziguinchor. And I'll just add that the Senegal is francophone, and in these villages, the adults tend to be, for the most part, are multilingual. Schooling is all in French. Most of the adults have spent some amount of time outside the village or go back and forth for work and other reasons. But the children are brought up monolingually in Egima up until school age. So it's a good place for looking at the role of input. What we've also examined to some extent how monolingual the input is, and yes, there's a small effect of Wolof, which is spoken in Senegal as quite a generally understood, mutually understood language. But these villages, for all practical purposes for the children, are monolingual to start with until they start school in French. So I think that's important to note at the beginning. And also acquisition has been looked at in Niger-Congo, but not in the Atlantic languages. So that's the family that Egima belongs to. And like a lot of other Niger-Congo languages, Egima assigns nouns to one of 15 classes or 10 genders. The way we're going to talk about this now is that classes refer to morphological noun classes marked by prefixes, noun class prefixes, and gender refers to agreement, which is marked on various other elements that agree with the noun. Number is marked by alternating noun class prefixes on a particular lexeme. and as well on all the agreement targets. And prefixes and the agreement target, the agreement markers are usually phonologically related. So there's a lot of alliterative agreement, but not always. We're not going to get into this in this talk, but there's both non-alliterative agreement and there's mismatches in terms of semantics versus morphology, and that's going to be an interesting thing for us to research, but we haven't, that's not the topic of today. So just to give you an example of how this looks, in example 1, you can see the lexeme branch, gan. So the stem is an, and the noun class marker is ga. So this belongs to gender 5, and it's singular. And you can see the alliterative agreement in gan, gagu, gutuje. So the definite article and the completive form of break both agree alliteratively with the prefix associated with the word branch. And in 2, you can see the proform nde, and nde takes, when it's referring to branch, it takes the same noun class prefix, gande, gagu, gutuje, it triggers the same agreement throughout, without actually referring specifically to the branch. So it takes the agreement markers and the same prefix to refer to the same referent, but nde itself is a generic proform. So with alliterative agreement like this, and you can see it's quite salient, the alliteration is likely to facilitate acquisition of both the class of nouns and the agreement, but also the classification of nouns is generally semantic. So there's a general underlying semantics that informs most of these noun classes, as well as some arbitrary assignment. And as you saw in example 2 in the last slide, the dummy stem, or the proform nde, thingy or thingamajig, can combines with the prefix of the referent it's referring to. It can combine with any of the noun class prefixes, and that can be semantically based or can refer to lexemes, specific lexemes. So the noun lexemes themselves are assigned to a nominal class via their prefix, but they can also take different CPs, the noun class prefixes, based on semantics. So just to illustrate that, here's gan again, branch with a singular prefix, 1 with branches. So you see the contrastive plural marker for branches. And then you can also replace that with jian, which gives you a diminutive singular, and muan for small branches, small branches. So muan would be diminutive plural. So you have a prefix that is associated with the stem to give you the noun class, but there's also use of contrastive prefixes. So here are just some more examples that show the underlying semantics that you get in these in the gender classes, in the genders. And gender 1, you have human denotation, so a as a prefix gives gender 1, which generally includes only humans. So arroka, you have worker, and ande as is again this proform, and it indicates someone or whatchamacallem, something like that. So it gives you this idea of humanness, a human something. Gender 6 refers to small entities. So this is generally it either refers to small things or it creates a diminutive of whatever noun it's attached to. So juroka is small worker. It's kind of a funny form. And jinde is small thing, small thingamajig or thingy. And we have tinach is an example of gender 8, which gives precise location. It can be used as a locative, but this example is actually means sun or time, and used with the dummy, the proform tinde, you get some sort of precise location there. So it's generic, but precise location. Okay. So our question in approaching this study was, what kind of evidence can we look to of morphological acquisition? What we really want to see is productive knowledge of the morphological system. So, we're using a usage-based approach where we're not imputing knowledge to the child that we don't see positive evidence for. And we're assuming that children first learn words and combinations as whole units, so memorized chunks, and then based on an inventory of lexical items and combinations, they begin to expand these patterns to new words and new combinations based on analogy with what they already know. So just the use of particular nouns together with particular prefixes doesn't necessarily indicate morphological knowledge or morphological productivity. So we're going to ask what to look for then to indicate knowledge of the system, emergent knowledge of the system. So if the prefix in the noun can be simply memorized, but noun stems can have alternating prefixes, then we can look to those prefix alternations to uncover what sort of morphological knowledge children are indicated to have, as well as what sort of semantic knowledge they have of the entities that they're referring to. So here, it's very useful to look for singulars and plurals, diminutives, augmentatives, things like that, that involve prefix alternation. And we can also look at the other direction where we have prefixes that are used with alternating stems. So either one of those tell us that we see some sort of analysis of the whole chunk. We're not just seeing whole chunks used only as whole chunks. We can also, what's typical in acquisition is to look for errors in morphological production that can also reveal morphological system building, especially when we see errors that are based on overgeneralization, for instance, or resorting to more frequent forms that lead to erroneous usage. And finally, this proform nde that I have introduced is also a really useful one to indicate morphological knowledge of the system, because nde is used with various prefixes, and you need some sort of external knowledge outside of just the lexical item itself to use it accurately in a particular context. Okay, so the research questions that we began this particular study with were, first of all, when do we see evidence of productive knowledge of a noun class system based on the things I just listed? And second of all, what's the role of semantics in the acquisition of noun classes? Now, I should say, before even discussing the results, that that right now we have more questions than answers in terms of the semantics. We can see that semantics plays a role. Some of this morphological system is quite heavily imbued with semantics, and there's some nice indicative data, but there's quite a lot more that needs to be done here. All right, so what sorts of results do we have so far? Sorry, before results, let's look at the method. This is based on a 3-year study that had some extension as well. So it's just completed, or the funding has just ended this last year, funded by the ESRC and AHRC in the UK. And we've built a naturalistic corpus of child speech together with their caregivers. All the recording has been done in the villages where the language is spoken, with children who are, as I said, monolingually growing up with Ekima. And it's based on 2 groups. We have a longitudinal group of 6 children recorded every 15 days with some gaps, starting around age 2. Some of them we've begun from as early as age 110. and going up for 2 years till around age 4. And then we have a cross-sectional group that consists of 10 kids, each of them recorded once at age 3 and once at age 4. So we have a larger group, larger mass of data at age 3 and age 4 to compare across 2 time points. You can see in this picture, there are, the kids are adorable, and we have local assistants who have been doing the recordings. These are in the picture, you can see the 2 people who've been leading the recording and transcription team. And we've got a fantastic team of native language assistants doing the transcription, but that's been an incredibly labor intensive and slow process. So the transcription and the coding is still ongoing. So we've only got a small portion of the data that we can report on today. The children interact with multiple playmates in a lot of the recordings, and in addition to their parents, they interact with multiple caregivers, and there really isn't any way to control that completely. So the recordings have a minimum of 2 and up to 13 participants, which of course makes transcription more complicated as well. The data included in this study, just looking at the time and realizing I need to speak faster. So okay, that's good. I wasn't sure how late we started. So the data in this study includes 6.5 hours of recordings, from which we have 1,465 transcribed child utterances that we've drawn from 3 age groups. So we've selected recordings from age 2, 2.5, and 3 to be able to look at the development there. But at present, these aren't drawn from the same children, at least it's not all the same children. So 2 of the 3-year-olds are in the cross-sectional group, so we don't have their earlier data. So as more of the transcriptions get completed, we can do a little bit more actual individual longitudinal tracking of what sorts of nouns and morphology they're using. Okay, so first of all, we asked, how much do children use stems with contrastive prefixes? So because nouns are almost always used with a prefix, a usage with a particular prefix, the correct noun class prefix, doesn't necessarily show knowledge of the system. It shows knowledge of that particular lexical item because it can be memorized, rote learned. But we do have examples of contrastive prefixes. So here's an example of a child whose pseudonym is Muna at age 3, who uses the noun stem tin, that means eating or food, with 3 different prefixes. Beautiful. It's exactly the sort of thing that we're looking for. So we have etin, singular, fitin, plural, and mutin, a diminutive. And that, of course, suggests a certain amount of systematic knowledge of the noun class system by age 3. We also have examples earlier than age 3, but we don't have a lot of examples of contrastive usage. They're only found in a small proportion of the noun lexemes used, as you can see in this table. So here we have the 3 age groups. The total number of stems used at each age point grows, the diversity of the vocabulary grows, but the amount of stems alternating stays relatively constant. It's low, and in fact, at age 3, there are even fewer alternating stems, with a lot more total stems, and so we have quite a low percentage of stems used with contrastive prefixes. Probably just related to not having occasion to use these different prefixes. So that doesn't tell us much about knowledge of the system. On the other hand, prefixes used with contrasting stems do show, indicate a little bit more development, so or are more indicative of development. So here we've got the total number of prefixes growing slightly from age 2 to age 3 across these recordings, but More importantly, at age 2, we only have a third of the prefixes used contrastively on different stems. At age 2.5, we have half of them used on different stems. And age 3, we have almost all of them, nearly 90% used on different stems. So that's indicative, but it's certainly not definitive. So next we can look at semantic overgeneralization. And for that, we can look to errors and we can look to the generic proform to find evidence of system building and see when that starts coming in, when it starts looking productive. So first of all, errors, which is a logical place to look in acquisition studies. We have a nice example, again, from Muna at around age 3 in 4, where the child is using the augmentative prefix with the noun thorn, which, according to my colleague Serge, is not an accurate usage. It's not just evaluative morphology. It really wouldn't be used like that, and especially not together with the adjective big. So the adult target form, you can see in B, is ejeng yamach, and Muna uses gajeng gamach, and is not only using an overgeneralized prefix, but also agreement. So he shows incorrect usage and systematically applies that that usage with the through the agreement. So that's nice, but there are very, very few errors. So really the children are using the use of prefixes that they do use is highly accurate. So we need to look elsewhere. So we look to the proform nde. This, happily, is an item occurring frequently in the input, and it occurs early in child speech. And as I said earlier, it can occur with any of the prefixes. So you get unde for a human thingy or human whatchamacallem, finde for a round-shaped thingamajig, and it can be it can take any of the prefixes. So what do we find in the children's speech? Well, they do use nde quite early. At age 2, they have productive use of it, but they don't show alternations. So we don't know necessarily what their knowledge is, but they're not showing productive knowledge. Whereas at age 2.5, we do have contrastive use of prefixes with nde. Jandi, one of the children at age 2.5, uses 4 different prefixes with nde, including 1 plural. And Sanum uses 3 different prefixes out of 4 tokens, including 1 diminutive. And at age 3, we have even more tokens. And again, contrastive usage, including diminutive plurals now and 1 flat-shaped object. So here, it looks like, in addition to the alliteration, children are relying on possibly the physical properties of the referent, as well as knowledge of what prefixes are assigned to the lexical items that are associated with these referents.
Your time is almost up.
Okay, thank you. So the absence of the form-based cues to account for diversity of the prefixes used with the proform nde lead us to postulate that children are using referential semantics in productive morphology at 2.5 at least. But we could also ask whether the child is actually has a more specific lexical item activated from their repertoire, just not selected. So it's possible that the child is referring to a lexical item associated with the referent they're referring to with the stem nde, and are calling on the prefix or drawing the prefix from that. Based on the data that come from this corpus, we can't tell the difference between these two. So what we have is evidence of early productivity and system building, even from age 2 with stem and prefix alternation. Very few examples of erroneous prefix usage, but emergence of some sort of semantic alternations from age 2.5, both with prefix alternations for things like plural and evaluative morphology, as well as use of the proform nde. Now, what we really want in order to determine the role of semantics is to have more examples, more data, as well as more controlled stimuli. So we have planned an experimental study eliciting use of prefixes to test productive knowledge and to test what factors most affect accuracy, both in terms of generalizing prefix usage as well as just based on the vocabulary items that that are in the children's repertoire based on the frequency and the input and size of the noun class. We piloted this study a year ago in January of 2020, but as you can guess, the actual study has been delayed due to the global pandemic. So, so stay tuned. Hopefully, we'll have more interesting data to report and more thoughts about how big of a role semantics plays in the future. That does bring me to the conclusion of this talk. Thank you very much, and I'm happy to take questions or comments.
Thank you, Vervi. Do we have any questions? As I said, you can put your question in the Q&A section. You can also put that in the chat room, or you can also raise your hands. No questions? Okay, then thank you so much, Vervi, for your very interesting and informative presentation.
Thank you.
This is the very first time I hear research on this particular language, and so thank you very much. If we don't have any questions, let's just move on to the second presenter, which is Amalia Skilton from University of Texas at Austin. And her presentation topic is children acquire non-egocentric demonstrative later than egocentric ones. So let's welcome Amalia.
My name is Amalia Skilton, and I'm going to be speaking today about the acquisition of demonstratives, or words like this and that, in a language called Takuna. To begin with some roadmap, I'm going to be starting off by talking about the acquisition of demonstratives in well-studied languages like English. We'll then go on to some background about the Takuna language and its specific demonstrative system. We'll then talk about the methods of the study that I conducted to examine Takuna kids' learning of demonstratives, result in discussion of that study, and then conclude. To begin, I want to give you some background about the acquisition of demonstratives in English, because that's the language where we know the most about demonstrative learning. What we see in the acquisition of English demonstratives is a pervasive pattern of, on the one hand, early emergence, and on the other hand, late mastery. On the side of early emergence, demonstrative words like this and that, here and there, appear very early in the acquisition of English, normally during the one-word stage between a child's first and second birthdays. Eve Clark argues that within the one-word stage, there's some of the earliest words, appearing among the first 10 items and always within the first 50. The details of that claim have been disputed, but it is clear that they're among the first couple of hundred words, and they're definitely among the first function words. As well as appearing very early in type terms, they're also very frequent in token terms in kids' early production. They can make up between 7 and 10% of all word tokens for 1-year-olds. And that's a claim from Gonzalez-Peña, based on data in Schildes. So these are both emerging very early at the type level and being used very frequently at the token level. But at the same time as we see that early emergence in English, we also see late mastery. So kids' early production of demonstratives, like during the one-word stage, is clearly not adult-like. For example, kids in that stage frequently have no contrast between proximal demonstratives like here and distal ones like there. Additionally, experimental work, again by Eve Clark among other people, has shown that adult-like comprehension of demonstratives doesn't occur until very late in development, as late possibly as 6 to 7 years. So on the one hand, we're seeing these items emerging as some of the earliest stages of language development, but we're not seeing them being comprehended and used in an adult-like way until the very, very end of first language development. That pattern of early emergence and late mastery is found in English, but it's also found in other languages too. Studies have also seen this same pattern of early emergence and late mastery in Spanish, Turkish, Mandarin, and Yucatec Maya. So a genetically and typologically pretty diverse group of languages. And when authors try to explain this phenomenon, what they usually rely on to explain late mastery is the idea of children's cognitive bias toward egocentrism. And what I mean by egocentrism is not something like difficulty with false belief representations, but instead is that children prefer to construe reference in space based on their location relative to them, rather than their location relative to other participants or relative to other objects. And because children have that egocentric preference for how they represent objects in space, they tend toward egocentric interpretations of other people's tokens of demonstratives. So for example, kids will interpret here as meaning here near me, the child, instead of meaning here near me, the speaker. As a result, in a situation where the child and another participant are far apart, the child will interpret the other participant's tokens of here as meaning here near me, the child, not here near me, the speaker. So they're representing themselves rather than the speaker generically as being the deictic center. So the hypotheses that literature suggests about this pattern of early emergence and late mastery are really very simple. The claim is that early emergence is due to the very high frequency of demonstratives. They're incredibly frequent in CDS, they're incredibly frequent in adult corpora, and they're present in kinds of interaction that are privileged for learning, like joint attention sequences. So that's the source of early emergence. Late mastery, on the other hand, as I was just discussing, is due to the status of demonstratives as deictic. Because demonstratives are shifters, because their meaning and reference shifts with the person who produces them, understanding them requires construing reference from other people's perspectives. And that challenges children's spatial cognitive egocentrism, as well as their egocentrism in general. Now, what's important about these claims is that frequency and status as deictic are not properties of the demonstratives of any particular language. Instead, those are very robust properties of demonstratives across languages. And if we believe that early emergence and late mastery is due to those properties, we predict that demonstratives across languages, wherever they're frequent and deictic, will also display early emergence and late mastery. So let's see what that means for our study of Ticuna. So to give you some background about the Ticuna language, Ticuna is an indigenous language spoken along the Amazon River in Brazil, Colombia, and Peru. This map shows the approximate location of the territory. It is a language isolate. It has between 40 and 70,000 speakers, depending on what source you believe. And it's the most widely spoken indigenous language of Brazil. And there's a variety of documentary works in the language. I've cited some of them here, but none of these works discuss language acquisition or semantics and pragmatics, so I won't be referring to them further. The data that I'm presenting today comes from my fieldwork in the town of Cuchiacocha, Peru. That is the extreme western end of Ticuna territory, as shown on the map. Cuchiacocha is a titled indigenous community, so equivalent in American terms to a reservation, that has about 5,000 people. Its language environment is mostly monolingual Ticuna. Cuchiacocha is not an especially isolated place, contrary to what I think many people expect about the Amazon basin. Rather, as you can see in this picture, it has power lines, paved roads, brick houses, and so on. But it also has a very high level of language maintenance. I've conducted fieldwork in Cuchiacocha over about 13 months between 2015 and 2019. And I wrote a dissertation on the language's demonstrative system based on work with adults. So I'm drawing on that as well in this study. What I found in looking at adults' use of demonstratives is that Ticuna displays two syntactic categories of demonstratives: nominal demonstratives and locative demonstratives. Nominal demonstratives are words like this and that, and locative demonstratives are the equivalents to here and there. I'm going to focus in this talk only on the nominal items, so the this and that. In each syntactic category, there are 4 deictic demonstratives. There's more, there are only in 4. And those 4 are a speaker proximal, a speaker distal, diet proximal, and addressee proximal, as shown in this table. The speaker proximal can be paraphrased "this near me," conveys the referent is near me, the speaker. Speaker distal can be paraphrased "that far from me," conveys the referent is far from me, the speaker. Those two are semantically egocentric in that they relate the demonstrative referent only to the speaker. The dyad proximal and the addressee proximal are non-egocentric. The dyad proximal conveys that the referent is located between the speaker and the addressee, paraphrase "this between us," and the addressee proximal conveys the referent is near the addressee, so "that near you." The demonstratives undergo noun class agreement, and there are 5 noun classes. The agreement is mostly suppletive, so I'm not going to refer to demonstratives by their individual forms during this talk, so I'm just going to call them the speaker proximal, the distal, etc. Now, what I've just given you is a structural description of the demonstrative semantics, but I also want to underline some facts about their frequency. So this table shows you the frequency of each demonstrative per 100 words, not per 1,000 or 10,000, in a small corpus of adult-directed speech, specifically informal conversation between adults. What we find in that corpus is that the speaker proximal and the addressee proximal are both extremely frequent. Each of those items makes up about 2% of all word tokens produced by adults. So 2% of all word tokens are the speaker proximal, "this near me," and 2% of all word tokens are the addressee proximal, "that near you," in informal conversation between adults. The speaker distal and the dyad proximal are much less frequent, and in particular, the dyad proximal frequency is really very low. So given all of that background information, we can make 2 predictions about how demonstratives will behave in the acquisition of Ticuna. The first prediction is early emergence. We predict that, as in well-studied languages, the demonstratives of Ticuna will emerge in acquisition before the age of 3. I'm going to define that mark arbitrarily as early. Anything before 3 is early emergence. Anything after 3 is late emergence. Given children's cognitive biases toward egocentrism and also toward acquiring proximal terms more easily than distal terms, we would expect that demonstratives will appear in a specific order, and that order is the speaker proximal will appear first, followed by the speaker distal, followed by the addressee proximal and dyad proximal. That is based on cognitive biases and the belief in the literature that it is easier to learn egocentric terms and to understand demonstratives egocentrically than to understand them non-egocentrically. So the cognitive bias toward egocentrism predicts that we will see the speaker-centered demonstratives before the addressee and dyad-centered demonstratives. And that is not what we would expect based on frequency, because the addressee-centered demonstrative is in fact quite frequent. It's as frequent as the speaker proximal in ADS. So our prediction is these will appear before 3. The speaker proximal will be first, then the speaker distal, and the non-speaker centered items. In terms of late mastery, we predict, based on essentially English data, that no demonstrative will display adult-like production until at least age 5, because again, kids are not displaying adult comprehension until at least 6 or 7. We would expect production to take at least as long. Good, so I'm now going to discuss the methods of the study that I conducted to examine these predictions. So we conducted a cross-sectional study with 45 participants. The participants were aged between 12 months and 4 years, 11 months at the time of the tasks. They were weighted somewhat toward 1-year-olds in order so that we could examine the one-word stage in a little more detail. The recruitment criteria were very simple. The child's primary caregiver needed to speak Ticuna as their native and dominant language. The child needed to be typically developing, so no hearing loss or disabilities, and acquiring Ticuna as their first language. That was it. I do want to note that the majority of our participants not only are acquiring Ticuna as an L1, but it's their only L1. There are only 16 participants in the study that have exposure to Spanish. So this really is a study of a mostly monolingual population, similar to some work on Mayan languages by folks like Pedro Mateo Pedro. It's not necessarily comparable to bilingual samples like Latachi. So each child in the 45 child sample completed a total of 3 tasks, which I'm going to talk about 2 of them today. They completed a 30-minute object play session where they played with a locally acquired set of marbles, which is a common game for children of the participants' age in the community. And they also completed a 60-minute free play session where the child and caregiver could do whatever they wanted as long as they remained in the same room. I was present during the object play to operate the video cameras and make sure that non-target participants didn't come in. I was not present during the free play, and during that task, non-target participants like siblings and other adults were welcome to come in. Our goal in the object play was to get maximally comparable data, and our goal in the free play was to get maximally uncontrolled naturalistic data. And the data was recorded with dual camera video and body-worn microphones. So you can see a sample of the dual camera video in still image form here. The image on the left shows you what one video camera is recording. You can see the other video camera in the image, and the image on the right shows you what the other camera is recording. As we also have a waveform from recorders that the participants are wearing to get us a nice clean audio track. In post-processing, we transcribed and translated 20 of the 90 minutes of time per child, so 10 minutes from each session, and that produced a total sample of about 15 hours and 25,000 turns. Each of the 25,000 turns was coded for addressee to distinguish child-directed and adult-directed speech, and the turns were also coded automatically for the number of tokens of each demonstrative. I can answer questions about sampling, reliability, etc., which I know are concerns in Q&A. So in presenting results, I'm going to first talk about the production of caregivers and then the production of children. Data will be collapsed across session types because there were no quantitative differences in the production of demonstratives between object play and free play. For caregiver speech, we analyzed turns that contain at least one intelligible word of Ticuna, so not entirely unintelligible or entirely in Spanish, and that were directed to the target kids, not adults or other kids. About 10,500 turns meet those criteria, which is about 3/4 of all of the turns. Turns we excluded mostly were directed to adults. So in the adult's speech to the kids, what we see is that the speaker proximal demonstrative is the most frequent demonstrative. It makes up about 2.5% of all adult word tokens. The addressee proximal and the speaker distal demonstrative are much less frequent. They're each about 1% of all word tokens. The dyad proximal demonstrative, as in ADS, is very infrequent. Most adults don't use it at all in these recordings. So what's important about the adult-directed speech is that it's confirming, but the adult child-directed speech, excuse me, is that it's confirming for us that the addressee proximal remains relatively frequent in child-directed speech. Speaker proximal is the most frequent, addressee proximal is still quite frequent, speaker distal equivalent in frequency to the addressee proximal. That's important to know for the next slide. So in the analysis of kids production, we analyzed all turns, regardless of addressee, that could be addressed to anyone, and that contained at least one intelligible Ticuna word. That was about 5,700 turns. And again, that was about 3/4 of all the child turns in the sample. Most turns were excluded because they were not speech. They were things like laughter, crying, or fussing. And for the analysis, I'm going to divide the kids into 4 one-year age groups. The first analysis that I'll show you is in terms of demonstrative types. This graph shows the proportion of participants who ever produced each of the 4 demonstratives. You can see that for the speaker proximal demonstrative, this near me, it was present for the majority of 1-year-olds. For over 75% of 1-year-olds produced this item at least once. It was present at even higher rates among 2-, 3-, and 4-year-olds, as well as for adults. So children are acquiring the speaker proximal demonstrative very early. Most kids are producing that during the 1-word stage, and it continues to occur at higher rates in older age groups. The speaker distal demonstrative is a similar story. This is not as prevalent in 1-year-olds. It's produced by 5 of the 14 1-year-olds in the study. And then it rises very sharply among 2-year-olds. Most 2-year-olds do produce the speaker distal demonstrative, and it continues at about 75% prevalence across the other age groups, including adults. So the speaker proximal and speaker distal are both appearing very early. Speaker proximal is present for most 1-year-olds, and speaker distal is present for a significant minority of 1-year-olds. We are seeing a completely different story when it comes to the addressee proximal and the dyad proximal. The dyad proximal was never produced by any of the 14 1-year-olds, and it was only produced by 2 of the 10 2-year-olds. Then we saw an enormous leap in the prevalence of the addressee proximal in the 3-year-old age group. It stayed steady in prevalence in the 4-year-olds, and it hit ceiling in terms of prevalence for adults. So there is really an enormous developmental leap in the prevalence of the addressee proximal between the 2- and 3-year-old age groups. The dyad proximal is telling a similar story, but its prevalence is much lower across all age groups. That's to be expected as it is much less frequent than any other demonstrative. So to summarize what I just said, we are seeing English-like early emergence before the age of 3 for the egocentric demonstratives. The speaker proximal and the speaker distal are present robustly across all age groups. On the other hand, for non-egocentric demonstratives, we're not seeing early emergence, we're seeing late emergence at or after the age of 3. The addressee and proximal and dyad proximal are almost absent before 3. Even though kids in those age groups have other demonstratives, they don't have non-egocentric demonstratives. 1 and 2-year-olds only use egocentric terms. So that's a type analysis, but I also want to give you some information about token frequency. This is a graph of the frequency of each nominal demonstrative per 100 words for children in each age group. What you can see here is that children of all ages use the speaker proximal demonstrative a great deal. It makes up, in general, between 2 and 10% of all word tokens for kids between 1 and 4. 2-year-olds in particular really use this item an enormous amount. And in terms of pairwise statistical comparisons, 2, 3, and 4-year-olds are all using the speaker proximal demonstrative more than adults, and 1-year-olds are indistinguishable. So children use the speaker proximal demonstrative a lot, and they overuse it quantitatively in the 2, 3, and 4-year-old age groups. That is in stark contrast to the addressee proximal demonstrative. 1 and 2-year-olds, as I said, effectively don't use this item at all. 3 and 4-year-olds in general do have the item. Most of them do produce it at least once, but they produce it very, very infrequently. And in comparison to adults, there's a large statistical difference between the frequency of the addressee proximal for 3 and 4-year-olds versus for adults. Even though 3 and 4-year-old kids have the addressee proximal, they don't use it at adult-like frequencies. For the speaker distal and the dyad proximal, we actually don't see differences in terms of frequency between children 2 and above for the speaker distal or 3 and above for the dyad proximal relative to adults. So there's lots of evidence for late mastery in the speaker proximal, which kids overuse, and in the addressee proximal, which kids underuse. But there's not evidence for late mastery when it comes to the speaker distal or the dyad proximal. So this is essentially what I've just said. Children radically overuse the speaker proximal throughout development. They underuse the addressee proximal. In that, we're seeing both a type and a token bias against the addressee proximal, where kids both learn the addressee proximal very late, and even once they've learned it, they use it less than adults do. So to conclude, as a class, demonstratives and Takuna display the same pattern of early emergence but late mastery as we see for demonstratives in English. In terms of early emergence, some demonstratives, like the speaker proximal, are robustly present even for 1-year-olds. On the other hand, we're also seeing some evidence for late mastery. Some demonstratives, again, like the speaker proximal, are not attaining adult-like frequencies anywhere within the age range that we studied, so until at least 5 years. However, that early emergence and late mastery pattern only holds for egocentric demonstratives like the speaker proximal. The addressee proximal, on the other hand, displays late emergence and even later mastery. It's not present at all until 3 years, and it's used very seldom even by 3 and 4-year-olds. And we can't blame that simply on frequency in child-directed speech, because as we saw in the caregiver data from this study, the addressee proximal actually is equal to some earlier emerging demonstratives, like the speaker distal, in frequency. So this is an issue with children's capacity to use the addressee proximal, not with whether they hear it. It's not characteristics of the input, it's characteristics of the child that are driving this. So some questions for future research that I want to ask are, first, how do children index reference near the addressee when they don't yet have the addressee proximal form? I would guess, based on this data, that they're overextending the speaker proximal, since that's an item which they quantitatively overuse. But we would need a different kind of analysis in order to substantiate that. Second, I'm telling a developmental story here that's basically about cognitive abilities inhibiting the development of addressee proximals. To the extent that those cognitive abilities and the calendar of cognitive development is similar across populations, we would expect that addressee proximal demonstratives will also be showing up late in other languages. So that raises the question, how do kids learn languages that have addressee proximal demonstratives other than Takuna, like for example Finnish? How does the Finnish addressee proximal behave? And then last, does comprehension lead production in this case? In general, we do expect that, but we might not expect that in a situation like this where both comprehension and production are being constrained by concerns of theory of mind and cognitive development beyond language. That is all that I have to say. So I want to thank you for listening. I also want to thank all of the participants and families in this study, Untitled and Coursera, my Tacuna collaborator, and folks at the MPI Nijmegen Language Development Department who supported this study. Thank you, and you can find more of my work at the link shown here. These slides will also be up online.
Thank you very much, Amalia, for the video production. And Amalia is also available for questions if we do have any. As I said earlier, you can put that in the chat room, in the Q&A section, or you can simply just raise your hand to speak out your questions.
And I apologize in advance if my video lags or drops. I have a poor connection.
Okay, let's see. Here we have a question from Margaret. Let's see. First of all, it says, thanks, Amalia. How much did the session reflect children's typical language learning environment? Is CDS pretty frequent? If not, they also frequently learn from ADS because that is what they are exposed to. Maybe it would be best not to limit to CDS in the sessions. Or maybe this is less relevant since you think there is an internal, not external explanation for the kids' pattern. Also, my last name is pronounced Sikosh. All right, so that's the question.
Thank you for the question, Meg. I would say that the free play sessions are very characteristic of the kids' usual language learning environment. As I mentioned in the methods section, I was not present during the free play sessions. So I don't think that there's anything that would be inhibiting people from behaving as they normally behave, other than their expectations about what participating in a study would be like. I also, as you, Meg, are aware, but others are not aware, I also have long format language environment recordings of these same kids, where they're recorded for an entire 9-hour day by a body-worn device. And I have not analyzed those recordings to evaluate the quantity of CDS, but yes, it is my impression that CDS is pretty prevalent, and that children are learning from that as well as from ADS, I mean, as we expect cross-linguistically. But I cannot give you a quantitative answer about the comparability of the amount of CDS because I have not analyzed the long format data. So there are now 2 questions.
Yeah. Can you read those
one
questions?
Which is not a question.
Yeah. Well, the first one is not really a question, it's a comment. It says, thanks for the wonderful presentation. I don't have a question, but wanted to mention that your conclusion lines up nicely with my conclusion in my dissertation research. Well, the question disappeared. Let me see.
I answered the question by saying thank you. So I think that Diane Little-Martin also has a question. And then there's also a question in the chat about Noun Class. I can answer the question about Noun Class first. So yes, I would love to answer this question since it's relevant to both talks in this session. The kids are actually displaying remarkably adult-like use of Noun Classes. This is a language that has only 5 Noun Classes, so not as many as in many African languages with Noun Class. And also, the nouns across the Noun Classes are not equal in frequency. And some of the stimuli for this study, like the objects that we chose for object play, belong to the same Noun Class. So with respect to the object play data where we know what Noun Class they should be using, they basically are using that Noun Class. But I think that this is not necessarily comparable to what you're looking at because Noun Class agreement is suppletive. It's also not marked directly on the noun, and there are many fewer Noun Classes. Diane Little-Martin asks if there are pointing gestures that accompany the demonstratives, and if so, how they might be different for different types? Diane, thank you for that question. I almost always have questions about gesture in these talks, and I am interested in co-speech gesture. And this data has now actually been coded for co-speech gesture since I prepared this talk. That data has not been analyzed, but what we are seeing as a trend is that, of course, demonstratives frequently overlap pointing gestures. And in the case of the kids in this study, they are not displaying the preference for index finger pointing gestures that Western kids display. Instead, the kids are producing an equal number of index and whole hand pointing gestures throughout the entire time frame of the study, and there's no significant relationship between the proportion of index pointing gestures and their age. So we have not examined like the temporal coordination between demonstratives and pointing gestures, if that's what you're asking about. But in terms of the relationship between the pointing forms and demonstratives, it seems as though there's overall a low use of index points in these kids, and that's consistent with what my other work has shown about adults in this community.
Thank you. We also got a comment from Margaret. It says, cool, thanks. Do we have any other questions? No? Okay. I would like to thank you so much, Amalia, for your detailed data. And especially the data is from a very large sampling population. Now let's move on to the third presenter. That is Sammy Floyd from Princeton University. And her presentation topic is, can 2.5-year-olds use expectations about polysemy for disambiguation? Now, Sammy, please.
Thank you so much. And thanks to all the speakers for a really great session. And thank you, Dr. Chow, for chairing. And thank you to the interpreters, Nicole and Andrea. So today I'm going to talk to you about word learning. So if we want to understand how kids learn words, one potential strategy that they could use is called disambiguation. So if I show you these objects and I ask you to find the snuggers, you're going to be probably pretty likely to select the novel white items because you already know that the other objects are called spoons. So this behavior has been documented by many studies in children as young as 17 months. And it's also called mutual exclusivity. So past research has actually even found that young children can generalize a just disambiguated word to like additional exemplars, like in this case. So the green snuggers. So directly after disambiguating to guess that the white objects are snuggers without confirmation, children can then immediately generalize that label to more examples. So we know that by 2 years, kids definitely know how to use a known word and a known meaning to disambiguate other words and meanings. So this is useful so long as you know one of the meanings in the context, right? But what if the learner, like this child, doesn't actually know either label or meaning? This may be a phenomenon that children face, especially early on. Right. So, for example, this 2-year-old may never have heard of a bottle cap specifically, or has never heard a blender labeled or encountered it before. So the caregiver can go ahead and label both of the objects in an attempt to communicate or even teach. But unless there's any sort of indication, it's not obvious which is which, right? So disambiguation would be helpful if one of these meanings were familiar or indicated by the speaker. But here, let's say that both of these meanings are unfamiliar and it's not clear which one they're talking about in which order. So what is the child to do in this kind of case? So what this project explores is the possibility that children actually bring to bear what they know about other meanings of these words. So specifically, we want to investigate how they might use what they know about multiple meanings for the labels in question. So the child may not know about the kinds of caps that go on bottles, but they might know about the caps that go on heads. And they might be willing to accept that words have multiple meanings, potentially allowing them to extend that label to the similar meaning here at the bottle cap, right? If they know that the same word is being used in a new context. And if kids do understand how to learn an additional similar meaning for a word that they already know, this could reduce the ambiguity that they face in the world generally. It could potentially reduce referential uncertainty enough to map one of these novel meanings to a word. In this case, guessing the blender meaning for the form blender because they understand there's something cap-like that is likely to map onto the label cap. But this potential process I just outlined actually has sort of these two steps to it, right? We want to see if kids can use multi-meaning extensions of their knowledge in subsequent disambiguation of totally novel words like blender. But why do we even know the first step is possible, right? The step happening right here. Why do we even think that kids know anything about multiple meanings, or as it's actually called, polysemy? Right? Can they even use this weird property of language to reduce referential uncertainty if we don't even know that they understand polysemy in the first place? This ability can really matter for vocabulary, specifically understanding polysemy, because most words are polysemous, right? They have more than a single meaning, and those meanings are separate categories and concepts, but they do relate to one another. And some sources estimate that up to 80% of words are actually like this. In that they refer to multiple related meanings. So again, what you might notice about these three objects is that knowledge of one meaning might actually give you some idea what another meaning might be like, right? It might cover, it might go on top of something, it might be tight-fitting. And so the possibility that a word extends to similar meanings potentially makes the learning landscape less daunting. Instead of facing a bunch of unknown meanings and being unable to use any disambiguation strategy, maybe we can make inferences about new meanings sharing labels and then use those inferences to guide the disambiguation of those truly novel labels and novel meanings. So the question the study asks is whether polysemy can reduce referential uncertainty. So evidence about this comes from a few different sources. So older children can use a polysemous pattern with linguistic support to extend a label for a substance or material to an artifact made of that material, right? So some gup can be extended to gup. And we also know that by 4 years, kids can rapidly learn novel idiosyncratic sets of meanings. And this is important because natural languages have a lot of these, right? It's not just that they share the same shape or just the same material. They often have a cluster of related meanings that aren't actually all held together by a single rule or definition or pattern. But then we have to ask sort of, what about younger ages, right? These are like 3 and 4 or 5-year-olds. What about younger ages for whom this disambiguation strategy is actually relevant? So the ages at which kids really don't know as many words and are using mutual exclusivity, could that actually be an age at which kids understand polysemy to begin with? So I'll show you one study more concretely about younger kids that aims to address this as background, and then I'll move into the main studies. So in recent work, we directly tested how young children, specifically 2.5-year-olds, fare in recognizing multiple meanings for common polysemous words. Here you can see that there's drinking glasses and eyeglasses, baseball caps and bottle caps, bed sheets and sheets of paper, hot air balloons and party balloons, shirt collars and dog collars, and animal horns and musical horns. And we put toddlers in front of the eye tracker and tested each of these meanings. So both English meanings for cap were tested for word recognition on different trials. And to see if they extended this label to additional possible meanings that they've never seen before, we took polysemous extensions for that word that are attested in another language, specifically in this case, Spanish, but not attested in English. So tapa also means lid in Spanish, but not in English. And crucially, these are monolingual 2.5-year-olds. And to see, and to see the results. So what I'm showing you here is the proportion looking to target on this task. So meaning the baseball cap or the bottle cap or the lid over the word recognition window. So what we found is that those English meanings that our participants would have heard and seen with cap were more clearly recognized by toddlers. We also found that there was some understanding of these new meanings, such as lid. And these are meanings that our participants would never have heard, called cap. Right? And that condition is in gray, the novel extensions condition. So the reason I'm showing you this study as background is because it gives us a reason to believe that not only are kids tracking multiple meanings for words as they hear them in their environment, they also are starting to extend or entertain possible extensions for those words, right? They're prompted with a label that they already have meanings for. They're searching for candidate meanings that align with what they already know about that word. So to test this, we created a new iPad touchscreen task. To test the question about whether they can use those extensions to disambiguate further meanings, we created an iPad touchscreen task, and a sequence of trials would look like this. So let me press play here so you can see. It seems to be freezing. I'm sorry.
Look, a Tolver. There's a Tolver. There's a Tolver here. Can you find a Tolver? There's a Tolver here. Can you find a Tolver? There's a tannin here. Can you find a tannin?
So unfortunately, the audio and video seems to not be able to synchronize when I'm screen sharing. But the idea here is that you're presented with a novel word, you're taught what that means, you're tested on your retention of that word, and then you're asked to extend that word to a similar meaning, right? In this case, this object, which is made of different material and different colors, also novel. And then on a subsequent trial, without any sort of feedback about whether you extended correctly, you're asked to perform the mutual exclusivity disambiguation to a totally novel word. So I'll break this down again just so it's clear. What we saw was that a participant learned a new word and they were tested on it, that's in purple. Then they were prompted with two totally novel meanings and asked to find a meaning for that word that they just learned, that's in teal. And then finally, they were prompted with a new label for the same two objects, which if they were able to successfully guess that the similarly shaped wooden object is another meaning of Tolver, they should select the other novel meaning for this novel word, in this case, the orange circle. And we selected 12 sets of polysemous stimuli. We didn't just have Tolvers. And they were actually constructed to follow existing patterns of polysemy across languages. So 4 of them shared a texture, and that was meant to mimic the animal fur pattern that's been observed in many languages, where you can refer to a mink, the animal, and mink, the fur. And then 4 of them shared a material and 4 of them shared a shape. So one example of like the material extension from the real world is an artifact made of that material, the material tin, right? A tin is made of tin, and you can also refer to tin, the material itself. For shape, you might think of an entity with a different but similar shape, right? So a corner exists abstractly, like on a street, and also more concretely, like in a hallway. And the animal for example, for texture. So that's all taken from past literature. So just to remind you, these participants were tested on a word that they were taught in purple. Then they were tested on whether they could extend the same label to a similar word. And importantly, they were given no feedback. And then finally, in the last trial in this sequence in green, they were tested on whether they could perform disambiguation with a totally novel word, conditioned on the strength of their last guess of what the polysemous word extended to. And we tested a group of 2-year-olds. So the video I showed you was with a mouse that was screen recorded, but the toddlers used the touch screen. So what we found, I'll walk you through this figure, is above chance behavior on all 3 of these trial types. So first in purple, we see that they're learning the word that we're exposing them to, which is great. Importantly, next we find that kids are pretty successful at using that known word that they're taught from the purple trial to extend to a similar meaning. In fact, they're very good at it. And most importantly, in green, we found that kids were pretty successful at using an inferred polysemous word mapping to disambiguate a different novel word. So this is cool because it suggests that the polysemous extension, that even if the polysemous extension is labeled ambiguously, as it probably is in the world, given noise in the environment, with no feedback about whether that extension was correctly guessed, kids are able to use that information to sort of bootstrap and get a different meaning mapped. So you might then wonder actually how important it is that they see that polysemous meaning label, this teal trial, right? So if the idea is that kids can actually automatically extend this Tolver or the label Tolver here to this case, they should be able to go directly from the purple trial to the green trial here. So another reason to ask this question is more theoretical. So it's because you might wonder whether kids are just using categorization. Do they maybe view these things as the exact same category or variations of the same item? So if that were true, they should be able to automatically generalize the label and perform disambiguation on the same exact trial. So they should be able to skip this middle trial entirely. So that's the question we asked in study 2. So here is an example of what that study sequence, what the trial sequence would look like.
Look, a Tolver. There's a Tolver. There's a Tolver here. Can you find a Tolver? There's a tannin here. Can you find a tannin?
So again, we're getting some audio lag, but on this trial, the correct answer would be this novel object, given that you were able to correctly guess that this is another Tolver. So again, all participants had was a trial that checked that they learned a word that's in purple. And then in order to answer the pink trial correctly, they would have to implicitly or automatically extend that meaning to a new similar meaning. So what you can see here is that in the purple trial, they're still learning that novel mapping, which is great. We expect to see that from the last study, but they're really not doing well on the simultaneous extension and disambiguation trial. Even though they do this exact same thing in the first study I showed you, right? But they were given an invitation to make a polysemous extension on that previous trial sequence. So that invitation to extend a label seems to be really, really critical, right? It doesn't seem like they're automatically extending the label Tolver here to anything that looks vaguely like a Tolver. So what that seems to mean is that kids aren't going into the world expecting things to be polysemous in general without a motivating learning experience that includes that labeling. So once that possible extended meaning is labeled, there can be cascading gains in word learning like we saw in study 1, but without being given a reason to believe something is polysemous, it's not assumed. So we decided to test adults as well to see if anybody automatically extends labels to other similar candidates. We tested 30 adults on MTurk, doing the exact same study 1 and 2 that I showed you earlier. And we can see actually an identical pattern of data pretty much. So we, of course, see that adults are learning these novel labels when we teach them. They extend to the similar meaning, and they're able to then, once that extension is taught or prompted, once they're prompted with the label again, they're able to select that similar meaning, but And again, we see that they're able to use that to disambiguate, that's in pink, but really crucially, we're seeing a huge difference between disambiguation after the polysemous meaning in pink and disambiguation without that labeling experience, which is in purple, which is just like the kids I showed you in study 2. So adults don't go around expecting things to be labeled polysemously, even if those objects share shape or material or texture. They don't go around assuming that things are polysemous willy-nilly. They also require evidence that the language they're speaking uses a word polysemously.
Sammy, you have 4 more minutes for presentation.
Okay, thank you. So as a follow-up question, and to kind of try to understand this phenomenon, we decided to ask about the possible mechanisms that are responsible for the success that we at least saw in study 1. So the mechanism that we thought was most likely is categorization. So after all, we know from a lot of older work in psychology that kids can extend labels based off of category membership, right? So a blue, when they learn that a car is a blue car, they can also extend the label car to a green car. So is that possibly what's happening here? Is it as simple as that? So past studies have investigated whether categorization can serve as a basis for polysemy directly. Notably, Klein and Murphy tested whether polysemous words like paper, such as a newspaper organization, and physical wrapping paper were thought of as the same category by testing if participants would generalize properties across them. So generalizing properties is something that is pretty common, right, for categories. If 2 things share the same concept or category, we're likely to generalize a property we learn about one to another item of that category. So here's an example. They told people about a novel substance. So they said, suppose that scientists find the biotin bacteria in wrapping paper. What is the probability that the biotin bacteria will also be in liberal paper, as in a newspaper organization? So because our objects were novel, we told participants about internal physical hidden properties of our object, such as containing metal or having cement foundation underneath. So participants were adults on MTurk, and they saw one of these 2 pairs. The pairs were either from our stimuli on this side, or they were constructed to be same category versions of one of our stimuli, as in this photoshopped example, right? Or so we photoshopped our stimuli in order for it to be a different exemplar of the same item. So they were told the information in green. The object on the left has a cement bottom. How likely do you think it is that the object on the right also has a cement bottom? So we found that adults were less likely to generalize properties across our pairs of novel items than pairs of stimuli from the same category, right? So they do think of these polysemous sets of meanings as more distinct in category membership than 2 items that are very clearly of the same category. So it suggests that at least in our stimuli, categorization as it's construed sort of in old-fashioned psychology may not be able to account for kind of the broad generalizations that people are making across these kinds of items. We think some other more general process of generalization or a more complex view on categories could still be at play, but it's not as simple as a straightforward category induction kind of task would predict. So together, we found that kids and adults require an invitation in the form of a label to entertain additional meanings for words, and neither adults nor children assume polysemy without this motivating label, right? So just because things share a shape, we know that shape is a very common cue to a common label, but that alone is not enough to assume that something will have the same label. But given a small amount of evidence that a word might be polysemous, kids then quickly use that potential mapping to disambiguate subsequent novel labels, allowing these guesses about polysemy to facilitate new opportunities for learning. We think this is pretty consistent with some past work on vocabulary. So it's consistent with the eye tracking study I showed you, where kids performed better on trials where they've heard the polysemous label used than the trials where they had to guess the polysemous meaning. And it's also consistent with work showing that in order to develop conventions on how to refer to objects, parents actually do a lot of scaffolding on particular word choices. So this is examples from like conversational pacts, right? Do you refer to a shoe as a shoe or a loafer? Parents are more likely to be the ones to propose those, whereas kids might be good at learning their family conventions, but aren't as good at creating the sort of referential pacts themselves. So in future questions, I'd like to investigate like whether these polysemous extensions are retained, right? Their children's ability to guess the other tolver. Does that translate to actually learning that additional meaning for tolver? Do they need more feedback for that to be possible? And I'm interested in whether these novel disambiguated labels are retained. And this is a question about disambiguation generally, right? In all these mutual exclusivity studies, there's been a lot of really interesting questions about to what extent disambiguation is actually an opportunity for learning, or is it just in the moment kind of facilitation of communication. I'd also like to examine, our polysemous extensions that we tested were very predictable and cross-linguistically validated, right? They were shape and texture and material, but what about real natural language? Idiosyncratic polysemy, such as chaining and multi-dimensional types of extensions, those might be even harder. And finally, to kind of hammer this out into a quantitatively testable theory, we'd like to build a polysemy-based disambiguation into computational models of word learning. So thank you to our wonderful PIs, RAs, and participants, specifically Larissa Oliveira and Matthew Weatherhead, who helped run the study, Chris Potter, Mira Nencheva, Lauren Emberson, and Taylor Martinez, who helped with design and other feedback on the study, and my advisors, Casey Lou Williams and Adele Goldberg, and all of our wonderful participants.
All right, thank you very much, Sammy, for your very stimulating findings. And we all know that the way kids acquire language is very interesting all the time. And here there is a question from Leah Gia, and her question is, you may not have answered to this, but if you care to speculate, I'd love to have your thoughts. The question is, what might happen with this kind of task in children who've experienced language deprivation, which is most prevalent in deaf children from hearing families?
That's a really interesting question. I can't say that I have any expertise on the topic, but one thing that's kind of that I would speculate is that this process of disambiguation is actually kind of tricky. And I think older kids, if they're in a situation where they need to use it, are probably better at it because it involves like a complex cognitive operation of like, oh, not that because I know that label, but this instead is probably what refers to this new label. So I might actually guess that if you don't have as many labels, but you have that but you're learning, you're suddenly learning a lot more labels a little bit later in age, that you might actually rely on mechanisms like this more, right? You might do more explicit reasoning about how to figure out what people are talking about rather than the kind of more passive or associative type of learning that we think might be more at play in younger kids. Right, because what I've talked about is kind of a strategy, and I think older kids are better at strategies, and if they don't know as many labels, but they're able to use those strategies, then yeah, they may do so more. That's a really interesting question. Thank you, Leah.
Thank you, Sammy. There is another question from Michael Israel. It says, interesting that children perform below chance in second experiment on the mutual exclusivity test. I'm wondering how you might differentiate learning vague meaning from learning more disjoint polysemies. Is your future work on idiosyncratic polysemies geared toward teasing apart some of this?
Thank you. That's a great question. So Actually, the part of the last study I talked about, or the first study I talked about, that's actually more geared towards answering like what is vagueness versus learning multiple distinct meanings, because in this case, what we actually see is that the items that kids have had experience with that distinct meaning, they do significantly better than if they're exposed to kind of a like good candidate for, right? If you have a very general, vague representation of CAP, you should do really well on this trial as well. And they do well, but not nearly as well as they do in this case. And that to me suggests that there is some item-specific knowledge that's already happening here that kind of boosts performance of these recognizing these distinct meanings better than just a meaning that would fulfill a vague definition, which I think is this kind of meaning. And yeah, in general, I think testing your idiosyncratic or irregular polysemy, I think is absolutely the way to go, because if you can explain how that happens, then you don't have to, you can kind of explain how these more principled or regular patterns like shape, texture, and material might emerge from a learning process that can really start from less.
Thank you. We have another question from Misha Becker, and the question is, in study 2, you did not tell kids along with dimension polysemy could be extended, shape, texture, material, there is also function. So isn't that the missing step rather than not expecting words to be polysemous?
Yeah, I mean, it's an empirical question if that would, if how much that would help. I'm sure it would improve their performance, but I'm not sure I would consider it to be very naturalistic, given that not even adults notice a lot of polysemy who aren't linguists anyway, notice like that multiple meanings of a single word often share some similarity or have a relationship like shape and function. I'm not sure how it would be possible to kind of convey that idea to 2-year-olds, but I think maybe if we were to sort of prime them with like shape consistency being something that appears, but actually there is some data for this. So Linda Smith has shown that, and colleagues like Jessica Horst and Larissa Samuelson have shown that actually young kids are learning that shape bias. So they're learning that things of the same category or label share a similar shape. They need to develop that, and they learn that through exposure to language, right? So it's actually it seems like it's the other way around, where the more nouns they learn that have same shape as the thing shared across the meanings, the quicker they are to then learn to use shape as a principle for extending something. So it seems I would guess that they need sort of that item specific experience, and then they can generalize.
Thank you very much. Our time is up. Well, here I would like to thank all the 3 speakers, Sammy, Amalia, Vervi, for your very interesting and stimulating presentations, especially the interesting findings. And at the same time, I would like to thank all the audience for your time and also the questions. And thank you, Travis, for the tech support. It's my honor to be meeting all of you. Thank you so much. So this session is adjourned.